Welcome to Coding Made Easy. Today we are going to discuss the problem combination sum. Given an array of distinct integers, candidates, and a target integer target, return all the unique combination of candidates where the chosen number sum to target. You may return the combinations in any order. And the same number may be chosen from the candidates an unlimited number of times. Two combinations are unique if the frequency of at least one of the chosen numbers is different. So let's go to explanation. Suppose if you have an array, if you have the combination 2, 3, 7. So what are the possible combinations of 2, 3, 7 in which you can repeat 2, 3, 7 unlimited number of times to sum to 7? The answer is we have two combinations to be precise, 2, 2, 3, and 7. So here we are saying combinations and not permutation because the answer say 2, 3, 2 is considered as a duplicate. It's not considered as part of the answer. So the number of frequency of each integer should be unique for each answer. So let's think on how to solve this. We'll use depth first search for this. So the way we can think is, say, assume we start with 0. Okay, we are getting a target sum 0. There is only one way to go. And then suppose from 0, we have three options. We can explore three paths, 2, 3, and 7. Suppose we choose the path 2, then we got a target sum 2. So now the problem becomes, can you achieve a target sum of, we already achieved 2, right? So now the target sum becomes 7 minus 2, 5. So can we achieve a target sum of 5 using the collection same 2, 3, 7? So that's the problem we are solving here. So then if we explore 3, for example, the problem becomes we already achieved 2 plus 3, 5. So question becomes, can we achieve the target of 7 minus 5, that is 2, using 2, 3, 7? So that's how it goes. So that is how we are exploring. So when we do that, say if we first we chose 2, 2, 2, and then 2 became 8. So we overshot. So this path is not considered. So then let's see another path which is considered. Say 2, 2, and 3. So that is a good path. So we got a target sum of 7. So all these paths where we get to the target sum of 7, we are saying, okay, that's a good path. So record all the steps you took. You took a 2, 2, and 3, then put that to a list and add it to the result. So that's how we came up with the answer 7, and that was added. So if we come to an answer of a number which is greater than 7, that is a bad path. We should not explore that anymore. So we kind of stop exploring that from that point onwards. The other thing you see here is, suppose we explore 2 and then we explore 3. After that, from 5, we don't explore 2 anymore. So 2, 3, 2 is not explored because of the reason we stated. 2, 3, 2, 3, 2 will not be explored because 2, 2, 3 will definitely be explored. So 2, 2, 3. So this path is explored. So hence, don't explore 2, 3, 2. So that should not be explored. So that is why once we take 2, 2, and then if we move to 3, then don't come back to 2. So it's always going right. So suppose if we go explore 3, then from that point onwards, do not go and explore 2. So this should not be explored because this is 3, 2, right? So that will be already explored in 2, 3. So this will be already explored. So if we explore 3, 2, it'll be redundant. So that's why we skip exploring the whole 3, 2 and the whole path from bottom onwards. So, and whenever we reach leaf of 7, we add that to the answer. Otherwise, if we reach a leaf of a number greater than 7, then just stop exploring. That is no longer the right path. So let's go and write the code in Python. So we will use the depth first solution. So we can have a return array, which is basically, which will contain all the paths. We'll call DFS target. So we can create a wrapper for, we can create a function DFS, which would have the candidates, then the current index, target, and this is the current path being explored, and this is the list of all paths. So let's write that. Self. So here we are saying target is less than 0. So in the difference in implementations, we don't write 0. What we pass is 7. And here we pass, instead of 2, we pass 5. Then here 4, instead of that, 3. Then 1. Then here it'll be -1. So by this way, we need not keep track of two numbers like the 0 and the target 7. So this is, we store as complements so that we can keep on decrementing. And when we reach a negative number, we say no. So that is the way we are implementing it. If target is less than 0, then we are done exploring that path. Otherwise, if target is 0, then that means, yeah, we hit it, right? So we can append the whole path to the ret, and we are done. Otherwise, now, so those two cases did not happen. Now what needs to happen? Suppose we are here. So we need to explore, we need to iterate through all the, so say we are at this level. So at this point, we are, target is 5. So we need to explore 2, 3, 7. So currently we are the 2. So we need to iterate through the entire list, and for each entry, we need to explore again the depth first search again. So for I in range of, we can start from index to length of nums, which is basically the array. Nums I, what will be the new target? Target minus nums of I. So there, so when we have 5, at this path, we are sending 3. At this path, it'll be 2. And at this path, it'll be, oops, it'll be -2. So that is basically target minus nums of I, then path plus nums of I. Let me, path minus nums of I. So basically to the path, we added the current element. Then we are also passing in the array, the final result. So once we are done with all this, we can return the ret. So let's run. Self.dfs. What is the problem? Candidates 0 target. Oh, it's the comma. Okay, so all cases are accepted. Okay, the answer is accepted. So that's it. Thank you, everyone. Hope to catch you up in the next video. Thank you. Bye.